Assalamualaikum and hi class. In this video, we're going to talk about how to interpret linear relationship. Okay, linear relationship between independent variable and dependent variable using correlation coefficient and coefficient of determination. So you're going to learn on how to calculate correlation coefficient and coefficient of determination, and also how to interpret the linear relationship using these two values. Okay, so let's go to the first one, which is correlation coefficient. It is also known as the Pearson product moment correlation, and the notation used for population is R, and capital R, and a small letter r for the sample correlation. Okay, population correlation is capital letter R, and sample correlation is small letter r. Okay, it is used to indicate the linear degree of a linear relationship between independent and dependent variable. Okay, so the correlation coefficient measures the strength and the direction of the linear relationship. Okay, and then its value range between -1 to 1. So R will never be bigger than 1. It also should never be smaller than -1. The nearer the value of R to 1 or -1, it means your linear relationship is stronger. Well, actually, there's a table that you can use to describe the strength and the direction of your linear relationship using R. If your R is -1.0, it means that your independent variable and dependent variable, your factor and response, has a perfect negatively correlation. Okay? If your R is between -1 to -0.7, then your factor and response has strong negative correlation. If your R is in between -0.7 and -0.5, it means your variables has moderate negative correlation. And if it's -0.5 to 0, it means that your factor and response has weak negative correlation. And if let's say the R calculated is 0, so that shows your factor and your response has no correlation at all. There is no correlation between the factor and response, meaning that they are not related. Okay, so the same way for the positive correlation between 0 to 0.5, it means it has weak positive correlation. Between positive 0.5 to positive 0.7, it's moderate positive correlation. Between positive 0.7 to positive 1, it has strong positive correlation. And if the calculated R is exactly 1.0, it means that your factor and response has perfect positive correlation. Okay, so how do we calculate this R value? So this is the formula to use. Okay, this is the formula that you can also find in your formula book. Okay, try to look up your formula book. Open up the pages and find out which page is this formula. Okay, so R is equal to Sxy divided by square root Sxx multiplied square root Syy. Remember, the value of R should only be within -1 to 1. Okay, so this is the formula of all these Sxx, Syy, Sxy. Okay, now let's take a look at an example to practice this formula. For example, now using this data, calculate the correlation coefficient value and interpret its value. So what data is this? It's about students' number of hours, student A to student H. So they recorded the number of hours that these students spent to study. Okay. Student A spent 5 hours, student B spent 8 hours, and so on. And then also they recorded their final marks. Okay, so in this case, number of hours is considered as the independent variable and final marks is the dependent variable. So logically, we would want to see whether the number of hours affect their final mark. Betul tak, kan? So in this case, we want to see is the number of hours spent to study became a factor to the final mark. Okay, so does increasing number of hours increase the final mark, or does increasing the number of hours reduce the final mark, right? If you look at this table, if you simply look at this table, we can somehow say that, you know, as the number of hours increases, and so is the final marks. Okay, but then you can't really tell how strong is the relationship. By looking at this data value, we somehow can say that, yeah, there is a relationship, you know, they are related, because you can see that as the hour increase, the mark also increase. So we can somehow intuitively say that there is relationship between these two variables, but you don't know whether is it a strong relationship, is it a moderate relationship, or is it a weak relationship. Kan? So yeah, that's why we need to calculate correlation coefficient. Okay, so jom. This is the scatter plot. If you were to plot this on a scatter plot diagram, this data value, okay, a number of hours as the x-axis and final marks on your y-axis, you will get this plot. Okay, so the A, B, C, D, and until H. So yeah, by looking at this plot, we can also see like they do represent a linear relationship. Okay, we can somehow see like as though there is a straight line. Okay, they do imitate a straight line, but is it strong relationship? Is it weak, or is it moderate? So that's why we need to calculate correlation coefficient. Now, how to do the calculation, guys? We're going to use this formula. Okay, so let's first you need to find all these three values. Okay, all these three s's: sxx, sxy, syy. Okay, so sxy is the calculation of summation of xy minus summation of x multiply summation of y divided by n. So that is how you calculate sxy. So how to get all this summation? Well, you can try to, you may want to construct this table, but this takes a long time. You can actually just use your calculator to get all these sum values. Okay, so again, you may want to construct this table, but I do not recommend you to do that. You can just use your calculator to get the sum of x, the sum of y, the sum of x square. You see the x is being squared, and then you total up and you get 908, and then the sum of x multiply y. So each x multiply its pair, its y. 5 multiply 49 and you get this. 8 multiply 60 and you get this. And you sum all this value, that'll give you summation of xy. Summation of xy, which is this one. Okay, summation of xy. Again, class, you don't need to construct this table. Just learn up how to use the calculator to get 5891 straight from the calculator without having to construct this table. Okay, and then the summation of y square is actually each y being squared, and then you sum up the square value, then that will give you 38784. So for sxx, it is summation of x squared, this one, minus summation of x. Summation of x is this, okay, divided by n. N is the sample size, which is 8. Okay, so and then syy is the summation of y squared, this one, minus summation of y, this one, divided by the sample size. Okay, so there are only 8 students, right? So the sample size is 8. So that will give you syy, and you substitute all these three s's into the formula, and you can immediately get the correlation coefficient, which is 0.9448. Okay, itu je. Alright, so the formula is not that hard to practice, but then of course you need to try in order to be familiar with the formula. Okay, so 0.9448. Okay, now this is your R value, class. Now let's try to interpret what can we say about the linear relationship between number of hours spent to study and the final mark. Is it strong, is it weak, or is it moderate? So for that, you should refer to this table here. Okay, so apa tadi? Positive 0.9448. Okay, so positive is on this side, 0.9448 is in between this range. So the linear relationship is a strong positive correlation. Okay, so meaning that now we can interpret that 0.9448 shows a strong positive linear correlation. There is a strong positive linear relationship between the number of hours students spend to study and their final marks. Those who spend more time will obtain better result. Logik lah kan? Sebab dia positive correlation. As X increases, Y will also increases. As the number of hours increases, the final mark will also increase. So class, this is correlation coefficient, how to calculate and how to interpret. Okay, next. Let's look at coefficient of determination. This is also another value that you can use to interpret the linear relationship. It is denoted by R square. Okay, it is the formula is very simple. Just like how the notation represent, it is the square of your R, the square of your correlation coefficient. So now we're going to talk about coefficient of determination. The formula is R square, the notation is also R square. It is also known as proportion of variance and interpreted as the proportion of the variance in the dependent variable that is predictable from the independent variable. Okay, for example, the value of R square is between 0 and 1. It should not exceed 1 and it should not be smaller than 0. It should not be negative sebab dia R square kan. Mana boleh negatif kan? Okay, so jom kita tengok. Example If R square is 0.1. Okay, if it is 0.1, so how to interpret? 0.1 R square means 10% of the variation in the dependent variable can be explained by independent variable, or 10% of the variation in dependent variable is predictable from the independent variable. Okay, kita terus pergi example lah. Using the result from the previous example, find the coefficient of determination and interpret its value. So simply square the coefficient of, square the correlation coefficient, 0.9448 square, and you will get 0.8926. So how to interpret this 0.8926? You just multiply by 100 to get the percentage. So 89.26% of the variation in the final marks can be explained by the number of hours students spend to study. Full stop. That's it. That is how to interpret this R square value. Meaning that the final marks has been influenced, has been affected ataupun affected lah by the number of hours spent to study by 89%. Meaning that 89% of the final mark is caused, okay, is explained, alright, is predictable by the number of hours students spend to study, 89%. The remaining 10 to 11% of final marks is due to other factors, okay, maybe any other study environment lah that could relate to the final marks. At least from this value, we can say that, oh, okay, number of hours spent to study has affected the final marks by 89.26%. Okay, class, is that clear? Now, I don't think you can clearly understand the calculations and the interpretation unless you try out an example, okay? So, for that, I want you to try this exercise 5.1, okay? Identify which one is the independent and dependent variables. Draw a scatter diagram. You may want to do this. You can also skip question B. I want you to calculate the summation of y, summation of y squared, summation of x squared, summation of xy using your calculator. Don't construct the table. Just use the function, the features in your calculator to immediately get all the summation values. Calculate R and interpret. Calculate R square and interpret. And then give your general comment of the student's performance. What do you think about the student's performance based on the interpretation you did in question D and question E? Okay, I want you to do this and submit in class notebook. Okay, class, thank you so much for listening in. I'll see you in our next virtual class. Bye-bye.